why is so much of the clinical budget or clinical research trial budget dedicated to not why isn't it dedicated to things like hyperbaric oxygen or diet, such as a ketogenic diet restricting sugar and glucose, when clearly there's tons of research and science to back that? One of the things that I sent you in the email was one of the things I came across was like 75%, I think 70 to 90% of U.S. clinical research funding is dedicated to drugs and medical devices, I think it was.
Yeah. Well, the National Institutes of Health is a major funder of research, right? And I think at least $50 billion, I think, per year to clinical research, and that could be drugs. And I know a small minority, not even 1% of that, is going into nutrition research. And with cancer,
which is insane.
Yeah, and with cancer, you have a number of different, things that are being funded. It's over for 2022. It's going to be over $200 billion in funding, and pretty much no funding goes into cancer prevention, right? So there's so much that we could be doing now to prevent cancer from being a problem in the first place. So we could prevent a lot of cancer through lifestyle interventions, like really, really, really move the needle. Like it's a huge lever to pull. So with, there's not a whole lot of incentive for funding nutrition, not a whole lot of incentive for funding hyperbaric oxygen. And I think that's part of the reason. And it's just easier to prescribe a drug, and to treat someone with the drug. And drugs do hold a lot of promise. We do drug research in our lab.
Yeah, well, you're big into pharmacology, or you?
Oh yeah.
You used, at least
I'm
you
in
used
a pharmacology department.
Right.
Yeah. We've looked at things like you might be familiar with, like metformin, for example. Metformin's a type 2 diabetes drug, and when we give it to cells, cancer cells in culture, more cells die. When we give it to animals that have, metastatic cancer, different tumors, they live a little bit longer. But it's not as much as if we apply a well-formulated ketogenic diet. We've used something called dichloroacetate. My colleagues do drug research with a variety of different drugs. And when you compare, research in preclinical animal models and with the ketogenic diet and what the ketogenic diet can do in extending life and reducing tumor, it's really remarkable. So, and some drugs actually work much, much better in the context of a ketogenic diet. So there's certain metabolic drugs like PI3 kinase inhibitors, for example, developed by Luke Cantley. I believe that they're mostly efficacious in the context of a ketogenic diet because, well, this particular drug, there's a counter-regulatory effect which causes an increase in insulin. And when you couple the drug with the ketogenic diet, that suppresses the hormone insulin, and then that actually makes the drug work. So a lot of the effects of the ketogenic diet is not just simply due by reducing sugar, but it has a major hormonal effect on the body, including insulin, the hormone insulin, and then insulin signaling in general. We're talking about AMP kinase and mTOR and all these. You can go down that route if you want to, but it's hitting many downstream pathways that the pharmaceutical companies are scrambling to develop drugs for. These pathways like mTOR specifically. So the ketogenic diet does that naturally. It does it in a way that it's not only hitting one pathway, that it's hitting many different pathways in synergistically, if you will. So by lowering glucose, lowering insulin and insulin-related signaling, and also elevating ketones. And then ketones by themselves have anti-cancer effects, anti-inflammatory effects, and neuroprotective effects. So if you put a brain tumor patient onto standard of care, which includes chemo and radiation, and you put them on a ketogenic diet, the ketogenic diet is putting metabolic stress on the tumor and making the tumor selectively vulnerable to those treatment modalities, including radiation and chemo. It helps you kill more tumor. Whereas the healthy tissues are benefiting from the elevated ketones because the ketones are actually protecting the healthy tissues from the inflammatory effects of radiation, the reactive oxygen species, so they're neuroprotective. I mean, we know that sort of from a lot of the research that we've done, right? Because we hit cells, we hit animals, we hit humans with very high levels of oxygen, and it basically causes a massive burst of oxygen-free radicals similar to radiation. But we are doing it in the context of elevated ketones, and we typically do that with like an exogenous ketone, like a ketone ester or ketone salt formulation. So we deliver like that. This? Yes, okay. Yes. The Keto Start product is the product that I use on a routine basis, and there are more powerful forms of ketones in terms of esters, but I probably wouldn't want to take them on a daily basis. But under the context of certain extreme environments, you can deliver ketones in a dose-dependent manner to be neuroprotective and also to improve performance resilience. So there's a breakdown of performance under certain environments, and we think that with the correct formulation of ketones or different energy intermediates, we can preserve that performance in extreme environments.
What did you say the number was again for clinical research in the U.S.? How many billion?
Yeah, I think, I'm just talking about the NIH. So
just the NIH?
Yeah, I mean, you have Department of Defense, NIH, many different organizations, foundations, and things like that, American Cancer Society. So for NIH, they have about 50 billion. And, that's not a whole when you think about cancer research in general, just from all the different organizations, this year is going to be about $200 billion. But the budget for nutrition is like less than 1% of that.
Less than 1% of that. And the United States is what are that here? The number 68th in the world in healthy life expectancy.
Yeah. I didn't know it was that low, but it's pretty low. And I'd like to just go back to like nutrition. When I talk about the NIH funded nutrition, they're really looking at like growth and development and preventing nutritional deficiencies. And maybe there's a big push now for NIH to understand personalized diets, like how certain diets affect different populations. But it's not in like the research that I'm talking about. You know what I mean? It's not like developing healthy eating to prevent or delay cancer or to increase your outcome, to improve your outcome if you have cancer. There's just not a lot of research in that area. Although I'd like to say that the National Cancer Institutes, because there's so much pressure and because there's an acknowledgement that cancer is in part a metabolic disease and probably in part a genetic disease too. There's a dynamic interplay between the two. The National Cancer Institute, they recognize that nutrition is a big lever to pull. And there's a lot of research funding going into this idea of using nutrition to improve certain drug therapies, right? So there's the drug therapies are still the main treatment, and nutrition is just really brought in to enhance the effects of certain drugs. So that's
so backwards.